Hello, in this video, I will be talking about discrete probability distributions. In your text, this is covered in chapter 5. The objectives are construct a probability distribution for a random variable and find the mean, variance, and expected value for a discrete random variable. Many situations in business, life, and social sciences involve assigning probabilities to all possible outcomes of an experiment and evaluating the results. So let's get started with the first definition of a random variable. A random variable is a variable whose values are determined by chance. It is a numerical variable that describes the outcomes of a statistical experiment in words. So here we have a continuous random variable, and the notation will be a capital letter X or Y, the circumference of an oak tree trunks in a specific forest. Why is this a continuous random variable? Because if you think of circumference of tree trunks in some forest, this is something that we measure. This is a measurable variable, so the result will be a continuous type of data. And in this context, this will be called a continuous random variable. A discrete random variable will be the result of counting. This is the notation X, and we have to actually state this in words, the number of branches an oak tree contains. It's a numerical variable, it's a numerical value, right? The number of branches. So it will be called a discrete random variable. The values of a random variable can vary with each repetition of an experiment. So more related to the definition of a discrete probability distribution. A discrete probability distribution consists of all values a random variable can assume and the corresponding probabilities of the value. The probabilities are determined theoretically or by observation. So let's think back of what we studied before, which was the frequency distribution. In this case, we are dealing with probability distribution. If you recall what a frequency distribution is, you should visualize a table in which you have the data. Sometimes you see the data, sometimes you see the classes the data belong to, associated with the frequency of each class. Now, in this case, we are changing the word frequency to probability distribution. So we will create a table in which we will display the values a random variable can assume and the corresponding probabilities. So basically, we are revisiting that idea of creating a table, but we associate probabilities to the specific values. And we will first talk about discrete probability distributions. That's what we will do in this video, but later we'll talk about continuous probability distribution. And sometimes we use this notation, PDF. This is point distribution function, and that's how we refer to a discrete probability distribution. Let's take a look at some examples. If you recall, the rules of probability distributions are, first, each probability should be a number between 0 and 1. And second, the summation of the probability of each possible outcome in the same sample space equals to 1. Here is one example that you will see. Find the missing probability that will make the distribution a probability distribution. In order to answer this question, first of all, we want to make sure that this first rule is covered, and then we have to check the second rule. For example, let's just take a look at this table. Are all of these probabilities between 0 and 1? Yes. So the first one is checked. What about the summation of the probability of X? Well, we have to simply add all of these numbers, and we will subtract the value we get from 1 in order to find the missing probability. So the summation of the given probabilities, it's actually 0.78. And this plus what we are looking for should be 1 which means x is 1 minus 0.78, which is 0.22. I will let the second problem for you to solve, identify this probability. You want to make sure you will add all of these other numbers and then subtract the summation from 1 to come up with what's missing there. Let's take a look now at another example. It says right here, construct a point distribution function for the random variable x outcomes of rolling a die. So we will simply take a look at the outcomes of rolling a die and the probability associated with it. That's how we will construct the discrete probability distribution. When I say discrete probability distribution, I am thinking to construct a table, and I can do this vertically or horizontally. And right here, we have to assume the values of the discrete probability distribution in the first column and the probability associated with these values in the second column. So I read carefully what the experiment is all about and what I'm looking for, and I'm looking for the outcomes of rolling a die. Well, we all know that the outcomes of rolling a die are the numbers 1 through 6. So these are all possible outcomes. These are countable. So we're talking about a discrete probability distribution. And I have to think of the probability of rolling a 1 when I roll a die. We all know that the probability of rolling each one of these is actually 1 over 6. Of course, assuming a fair die. We can check the rules of probabilities. Summation of this will be 1. And of course, these are all numbers between 0 and 1. So this is what we mean when we say construct a point distribution function or a discrete probability distribution. Let's now talk about this example. Construct a point distribution function or discrete probability distribution for this random variable. X is the number of girls in a family with 3 kids. When you are asked to construct a discrete probability distribution, you want to make sure you know what the random variable is. So make sure you read the information carefully. Most of the time, it will ask you to count something. Looking at this situation, you have to think, okay, I have a family with 3 kids. How many girls can there be? So if you think of this, you do realize that you can have 0 girls, or maybe 1, maybe 2, or 3 maximum. You cannot have more than 3 because you have only 3 kids. So these are the outcomes of this probability experiment. To construct the table, you will simply list these outcomes in a column. And in the second column, you have to identify the probability of each specific outcome. And that's why you need to know how to figure out the probabilities for each specific outcome. Let's see. We have 0, 1, 2, and 3. So how do I figure out what is the probability of 0 girls in a family with 3 kids? I will get the help of a tree diagram. I will just simply start at a first point and I'll say, okay, the first kid in a family with 3 kids can be a boy or a girl. And then moving on, I'm looking at each one of these as a task, right? When you use tree diagrams, you have to look at each possible outcome as a task, right? And continue with the process using the previous outcomes as starting points. So right here, I have from this B, the option of boy and girl for the second kid, and from this G, the option of boy or girl for the second kid. And now for kid 3, I will use all of these as starting points. So I have boy and girl, and then I have boy and girl, and then I have boy and girl. So you see, you need a lot of room to make sure you don't get lost between so many options. And the sample space will look like this. Well, you can have a boy, and another boy, right? Boy, boy, boy. And then you have boy, boy, girl on this branch, and so on. Make sure you list everything in this organized way so you will not miss specific outcomes. So right here, I have boy, girl, girl, and then I have all of these options. So this is the sample space of this probability experiment. However, for this problem, You are looking for a very specific random variable. So make the distinction. This is what you are looking for. You are counting the number of girls. So let's just take a look at this. What is the probability of 0 girls? Probability of 0 girls, I'm looking at all of these outcomes, which are 8. The only one with 0 girls will be this one. All the other ones have at least 1 girl in it. So I actually have 1 out of 8. What about 1 girl? I'm looking at 1 girl. This one is 1 girl. This one is 1 girl. This one has 2, so no. This one has 1 girl, and then I have 2 girls, 2 girls, 3 girls. So I have actually 3 out of 8. And if I continue, 2 girls, I will have 1 option here, 1 option here, and 1 option here for the 2 girls. So I still have 3 out of 8. And the last one will be only girls, 3 girls, which is this one right here. And that will be 1 over 8. And that's how you construct a discrete probability distribution for this random variable. As with any distribution, there are measures like the mean, standard deviations, and something that we call expected value associated with distributions. So we talk about the mean of a discrete probability distribution. To find the mean for a probability distribution, multiply each possible outcome by its corresponding probability and find the sum of the products. This is the formula. This is each possible outcome, and this is the probability associated with it. If you think of the table from the previous example, when we listed x and then we listed p of x, we simply multiply those numbers from the first column to the corresponding numbers in the second column and then find the summation. You will then find the mean. However, we will not be using this formula quite a lot. We have the calculator to help us with this, but this is how the formula looks like. The variance and the standard deviation for a discrete probability distribution. The variance is the weighted mean of the squared deviation of each possible value and the mean. Again, this is the formula as long as you have the information displayed in the table, which we call the probability distribution. After we find the mean, we can simply plug in the formula and find the variance. The standard deviation will be the square root of the variance, and of course the positive square root of the variance, because we know the standard deviation is always positive. However, as I said in this class, we will focus on using the calculator. So here we go. This is how we will be using the calculator in order to find the mean. So what we need to do is go to stats and then click on edit, enter the x values in list 1 and enter the corresponding probabilities in list 2. And then stat calc one variable stat, list 1 and list 2. So what it says right here is that the mean of a point distribution function is really just a mean, weighted mean of the values of the random variable x. We are doing the same procedure that we used for finding the mean of a frequency distribution in chapter 2. And you do recall that we've done the exact same thing. We went to stats and then edit. We entered the x values in list 1, and in list 2, we entered the frequency. Well, because we are talking about probabilities in the second column here, we will be entering probabilities in list 2. And all we have to do then, repeat the process and go to one variable stats, list 1, list 2. Under that screen, you will see the mean, and you will see the standard deviation and many other measures. Let's take a look at this example. Suppose we toss a coin 4 times in succession. First, find the PDF for a random variable x, then find the mean number of heads in 4 tosses, and then find the standard deviation of the distribution. So basically what we are asked to do, we are asked to identify the random variable x and construct a point distribution function, which is a table in which we display x and the associated probability. find the mean number of heads. So based on this, we know we are looking for the heads in 4 tosses and find the standard deviation. Let's take a look at the sample space. So if you will actually do this experiment, you will have these results where T stands for tail and H stands for head. You can see that you have 16 results, and we define X as the number of heads in 4 tosses. This probability distribution table is done horizontally. So on the first row, you have the values for X. On the second row, you have the values of the probability associated with X. The values associated with the number of heads in 4 tosses are 0, 1, 2, 3, and 4. So you can have 0 heads. And let's just take a look at this. This is one option where we have 0 heads. See? And actually, to come up with the probability, you'll have to figure out how many options do we have with 0 heads. Well, it seems that it's just this one out of the total number of 16. So the probability will be 1 over 16. If you look at 1 head, you simply try to identify how many options are there for 1 head. I see 1 right here, 1 head. I see another one right here, another one right here, and another one right here. All the other ones have at least 2 heads. So it seems that I have 4 out of 16. And so on. If you keep counting the number of heads, you will come up with a probability, and you can check that these are the corresponding probabilities. So what we've done right here was finding the probability distribution for this very specific probability experiment. What we will do next, we will answer the other 2 questions. The second question was related to finding the mean, and the second one, finding the standard deviation. So what I will ask you to do right now is plug in list 1, the values of X. You will have to plug this in, and in list 2 on your calculator, the values for the probabilities, which are this. And after you're done, you'll have to go to Calc and do 1 variable stats, list 1 and list 2. And if you've done this correctly, this is the result. X bar is 2, and this is the mean number of heads, and sigma X is 1, which is the standard deviation. You do realize that SX is missing, and that makes perfect sense because in a probability experiment, we are assuming that we are repeating the experiment over and over again. So the results that you see right here are based on the entire population, not sample. And that's why the notation for the standard deviation is sigma, not S. So this is perfectly okay. And X bar actually should be denoted mu, but the calculator did not change these notations only for this particular type of problems. So on your calculator, you will see X bar, even though if you were to write it down, you'll write it down mu, and sigma is 1. If you're asked to find the variance, you'll simply take sigma and square it. Let's take a look at another example, and I will let you practice with this one. It says the number of cartoons watched by a first grade class on Saturday morning is shown below. Find the mean and the standard deviation and the variance. Mean, standard deviation, and the variance. You already have the table. You do not have to construct it. So what you need to actually do is simply plug in the outcomes for the variable 0 through 5 in list 1 and plug in this P of X 0.15, 0.20, and so on in list 2. And after you plug that in, you'll simply have to do 1 variable stats. And under that screen, make sure you do not miss list 2 as the frequency list, right? You'll simply have to look for the X bar value and for sigma X. And the fact that SX is missing should be an indication that you are doing this correctly, okay? So this will be actually the answer mu, and this will be the standard deviation. For the variance, you take the standard deviation and you will be squaring it. We'll be talking now about the expected value, which is a very important concept with many applications in various games of chance, in insurance, and in cost-benefit analysis. So what is the expected value? The expected value of a random variable is the same as the mean of the probability distribution for the random variable. So basically, we are just using a different name. We call it the expected value. But what is the process? Well, the process of finding this is actually the same thing. We're finding actually the mean. We call it the expected value. The formula for the expected value is the same as the formula for the mean, is the theoretical average of the variable. Summation of x times probability of x. The symbol used is E of x and is actually, in fact, the mean, mu. Let's take a look at a couple of problems. And these are the applications that are used in real-life situations. A contractor is considering a sale that promises a profit of $26,000 with a probability of 0.7 and a loss due to bad weather, strikes, etc., of $6,000 with a probability of 0.3. What is the expected profit? Whenever you start doing this type of problems, it's a very good practice to make sure you identify the random variable. Let X be the return on the investment. So let's see what values can X take. Well, they say right here, the contractor can make a profit of $26,000 or a loss of $6,000. So the $6,000 are put it as a loss, as negative. So these are the two values, okay? In order to continue with this problem and find the expected profit or the expected value of this discrete probability distribution, I'll simply create the table. This is the discrete probability distribution. I'll associate each outcome with the corresponding probability. So I have the $26,000 in profit, and that can happen with a chance of 0.7 or 0.70. And I have a loss. Keep in mind, this is a loss, so I put negative value here, negative 6,000, with a 30% chance. So as long as you construct this correctly, you should have no problem finding the mean. The mean or the expected value can be found by putting this information in the calculator, list 1, list 2, and look under X bar, or because this is not very complex, you can just find the summation of X times probability of X, right? So in this case, we have 26,000, this is the first X, times 0.70 plus, and we have negative 6,000 times 0.30. So it seems that the answer is 16,400, which is positive, which is good. An expected value that has a positive sign, it's good. So this is how businesses are making decisions. They figure out the expected value, and even in those years when the contractor will lose money, overall, this is what this means. Overall, in a long term, they will make on average about $16,400 per job. So let's take a look at this example. An insurance company issues a policy against theft of a diamond necklace worth $50,000. Assume that the probability of theft in a given year is 0.2% and that the premium is $300 annually. What is the expected value annually for the insurance company? So here we go. We have to answer this question. We will denote X as the return for the company. It is right here in the question, right? X is the net return for the company. So let's see, what values do we have for X? Now, if you think about it, every year they will make $300, right? What is the probability that they will make this money? Well, it's equivalent to the 1 minus the probability that this necklace will be stolen, right? So the probability that this will be stolen is 0.2%. And if that happens, the company will actually lose $50,000 minus the $300 that they actually received. So we're talking about the values in terms of the situation when this is stolen or not. So if this is stolen, the company will lose this much money. If this is not stolen, the company will make this much money. Do we know the probability associated with it? Well, yes, we do. This is the probability associated with stolen, and 1 minus this will be the probability associated with not being stolen. Just keep in mind, 0.002 is the equivalent of 0.2%, okay? And to find the probability of not stolen, you just simply have to do this and figure that out, okay? I will show you the result. Actually, it's on the next slide. So this is what I was talking about. Here we have the table. We have 300 annually or a loss. The probability of making those 300 annually, it's actually, look at this, very, very close to 1. And that's how these companies actually make money. And the expected value is 200. Think of this as a long run. Let's take a look at another problem. 5 numbers are chosen from 0, 1, 2, 3, 4, and so on up to 9. So 1-digit number with replacement. You pay $2 to play. If you match all 5 numbers, you win $100,000. Plus, you will get back those $2. Okay? What is the expected profit of the game? Let's write this down. The random variable we are looking at now is the expected profit of the game, or the amount of money. Amount of money you profit. Okay, let's think of this situation. X, well, you can win $100,000 and they will give you back the $2, right? Or if you don't win, you lose. And if you lose, you will just simply lose your money. Let's create a discrete probability distribution for this problem. I have X and I have P of X. So my values for X are $100,000 and minus $2. What is the probability that you will win? They say right here, if you match all 5 numbers, you win. So on a side right here, I'm thinking of what I know about probability, trying to figure out the probability of matching all 5 numbers. They say right here it's with replacement, so I have no problems with that. That means probability that I'll match the first number and the second number and the third number and so on up to all 5 numbers, okay? Because these are independent events, right? I'll simply say, well, probability of matching the first number, it's actually 1 out of, we have 10 digits right here, right? So it will be 1 out of 10. And this will actually, the second one, 1 out of 10. So here is my result for probability of matching all 5 numbers, which is actually 1 over 100,000. So this is the probability of winning. Probability of losing will be 1 minus this. So I have 0.00001, and probability of losing, it's actually 0.9999, and I can just extend it to 999. So if I want to figure out what is the expected profit of the game, I'll write it down using symbols, and I'll simply multiply X times P of X. And if you do that, the final answer is actually negative 0.99998, which is approximately negative $1. What does this mean? This means that in the long run, someone who plays this game will lose on average $1 every time he plays that game. When the expected value is negative, it favors the house. When the expected value is 0, we're talking about a balanced game. If the expected value is greater than 1, it favors the player. Let's now take a look at this example. At a fundraising event, 1,000 tickets are sold at $1 each for a TV valued at $350. What is the expected value of the game if someone purchases 1 ticket? So let's identify X, the random variable. X is the amount of the game. We have 2 situations. Someone who bought 1 ticket can win the TV or not. So when the first situation happens, that person will actually win $349, considering that they paid $1 for the ticket. If that situation doesn't happen, they will lose $1. Creating the discrete probability distribution for this situation, we have these possible outcomes, 349, and then a -1. And let's see, what is the probability associated with winning the TV? Well, keep in mind there were $1,000 sold, $1,000, which means the probability of winning is 1 over 1,000, and the probability of losing will be 999 over 1,000. And to find the expected value, you either use the calculator or simply multiply each outcome by the probability associated with it. And if you do that, you'll come up with -0.65, which means that in the long run, there is a loss of 65 cents every time someone participates in this type of fundraising event. And now let's take a look at this final example. A charity organization is selling $5 raffle tickets as part of a fundraising program. The first prize is a trip to Mexico, valued at $3,450, and the second prize is a weekend spa package valued at $750. The remaining 20 prizes are $25 gas cards. The number of tickets sold is 6,000. What is the expected value of the game? I'll write down the given information right here because there is a lot going on with this problem. It seems to be a more complex problem. So, first of all, the ticket costs $5. This is the cost. There is a first prize, and that is valued at $3,450. It's a trip to Mexico. There is one second prize, and this is $750, which is a spa package. And there are 20 other prizes, and these are valued at $25 gas card each. And we know that the number of tickets sold is 6,000, okay? So it seems that we have 22 prizes right here. 20 prizes of $25 each gas cards, one prize of second prize, which is $750, and one prize, which is the first prize, valued at this amount, okay? And each ticket costs $5. So let's try to identify all possible values of the amount of the game for someone who buys one ticket. Think of this. They can win the first prize, right? Now, because they bought a one ticket, the first prize will actually be considered now $3,445. That's the first prize. Or they can win $745 because $750 minus the $5, or one of those cards, and each card is $25, so only $20. Or the last option, they win nothing, which is they will lose the $5. So these are all possible options. Let's see how this probability distribution looks like when we create the two columns and we think of the probability associated with each one of these particular outcomes. First prize, of course, when someone plays this type of games or they participate in this type of events, they always look at the first prize. That's why it's good to talk about probabilities associated with winning, actually. So what is the probability of winning the trip to Mexico valued at $3,450, from which we subtracted the $5? Well, only one ticket out of 6,000. Okay. What about the second prize, 745? Well, we will look at this as, well, this is another ticket, which can be the second prize out of the 6,000. Now, the next one can be a gas card, which is valued $25. So someone who actually gets that will actually gain only $20 since they already paid the $5. So how many of these are there? Well, we will say there are 20 such prizes. 20 divided by 6,000. And what about losing? Well, 6,000 minus 22, which will be 5,978 out of 6,000. In order to now find the expected value, you'll simply have to use the formula, and I'll let you do that, or take the calculator. This is a little bit more complex. Put this in list one, put these probabilities in list two, and then do one variable stats, list one, comma, list two. I'll let you complete this problem. I think coming up with this discrete probability distribution is the key. If you have this correct, you will be able then to find the measures like the expected values or the standard deviation or whatever is needed. You know how to do that with a calculator, but how to get this table and make sure that this table is correct, that is the key to solving this type of problems. With this, we conclude the video.